So let's rewrite that expression. Beta hat 1 equals the true value of beta 1 plus this amount, the sum, x1i minus x1 bar times ui over x1i minus x1 bar squared. And now we're going to take the expectations of both sides. So the expectation of beta hat 1, the expectation of everything on this right-hand side. So we're just taking the expectations of both sides. So this beta 1 is the true value. It's not a random variable, right? It's just a constant. It is what it is. We're trying to learn about that, but it is an actual number. It is the effect of education on wages. That is a number. It's not a random variable. So we're going to be able to take this, the expectations through this. So this equals beta 1 plus the expectation x1i minus x1 bar ui and so maybe I should make a note. Beta 1 is a constant. It's a number. We don't know what it is, but it's a number. Okay, so we have this expression. And now we're going to use something called the law of iterated expectations on this expectation, this big expectation here. So we're going to use the law of iterated expectations. In 4.3.5.1, don't worry too much. I'm not going to ask you to use it randomly on some test or anything like that. But the idea here is the expectation of y is the expectation of the expectation of y given x. And so we're going to apply that to this term. So the expectation in this term is the expectation of this with respect to x. So I'll just write out what we have here. So we're going to apply that rule. So we have this is the expectation of y. So think of this whole thing here as being the y in this expression, and then the x is going to be an x as well. So it's the expectation of the expectation of the sum of x1i minus x1 bar ui x1i minus x1 bar. It's the expectation with respect to x1. And then I need to close that bracket. Maybe I should have made these kind of brackets just match up what's going there. So I'm kind of applying this law here to this expression where everything in the square brackets here is the y, and we're just taking the expectation conditional on x, just like in this. And then we can use some of our assumptions we've been making about this relationship between u and x. So let's kind of rewrite that so we remember where we are. So right now we're at the expectation of beta hat 1 is equal to the true value, and then we just applied the law of iterated expectations on that other term. We have the expectation of the expectation, the sum of x1i minus x1 bar, hopefully I'm still on the screen here, ui over x1i minus x1 bar squared. And we're taking that second expectation. Let's just erase that. with respect to x1, close the circle bracket, and close this. Okay, and so now notice here we're taking the expectation of a bunch of x's with respect to x. So we can just move that expectation through, right? So the expectation of x given x1 is just x1. So we're going to use that to clean this up just a little bit for now. We're almost there, don't worry. So this expectation can go through. We still have this outside expectation, but now we just have the sum of x1i minus x1 bar. And here is where the expectation stops. And then we x1i minus x1 bar. That's that, and then we have the end of that bracket. So from here to here, we're just kind of using this rule to kind of bring this expectation through, but it gets stuck right there. So we're going to have to use an assumption we made about the expectation of u given x. Let's use this. Remember our assumption. Now I forget what number it is, I just wrote it down. The expectation of u given x equals 0, right? We made that assumption at the beginning, which means this equals 0, which means this whole term goes away as long as this is true. So this is a big, big assumption. So maybe I'll try to make that clear. That means this equals 0, which means this whole term, the second term, goes away because the expectation of ui given x1 equals 0, because that's the assumption we were making from the beginning. And so we're just left with this expectation of beta hat 1 is the true value. Well, this means beta hat 1 is an unbiased estimator. The true parameter. All right, so we just figured out that the expectation of beta hat 1 equals the true value. And so basically what, if you want to visualize what this is our distribution of this random variable, which is beta hat 1, right? It's a random variable because its value depends on which sample we draw, or its value depends on the sample we draw. And so what we're figuring out here is the mean of this is equal to 0. Oh, sorry, the mean of this is equal to the true value. Whoops. The mean of it's equal to the true value. So the center, the mean of this distribution is the true value, but now we need to think about the variance. And so remember, we'd prefer an estimator that has like a small variance, where a lot of the mass is kind of concentrated. This pen is bad. We prefer a variance in blue to the one in orange, if you can see the difference between them. And so we're going to be interested in, having these unbiased estimators and having the estimator's variance be the smallest. So we're going to derive the variance now.